So I'm going to quickly talk about comparing fractions. To compare fractions, you need to have a common denominator. I am going to kind of show you guys why that cross multiplying method works. I don't particularly like it because it's not getting you guys to compare the cake cut into the same amount of slices to the cake cut into the same amount of slices. But here I need to find the least common multiple between 3 and 8. It doesn't necessarily have to be the least common multiple. So what you could do is just 3 times 8. What is 3 times 8? 3 times 8 is what? What is it? 24. And 2, that's 16, right? And then this guy right here, 2 times 8 is 3, that's 24 again. And that's 15. So which one is slightly larger? It is this guy. So if I did happen to change these two negative numbers, would that change the direction of the symbol? And it would indeed change the direction of the symbol. Because remember, on the negative side of the number line, if a number looks bigger, it's actually smaller. So just make sure you do keep that in mind. But I'm going to erase those so that you guys understand that for this particular question, the answer is greater than. So why does cross multiplying work? It's kind of like a lazy method of finding only the new numerator. That's what it's doing. So 8 times 2 was 16, 3 times 5 was 15. That matches up to the new numerators we got down there, and we were just being lazy and not putting them over what should be the new denominator. That is why cross multiplying is an actual valid strategy for this. Now for this one, you guys may already know which one's greater just because of comparing a negative to negatives. But let's go through the process again of finding common denominators. Again, don't worry about them being the least common denominator. It doesn't matter. We're going to talk about finding the least common multiple, but I don't really see the reason to. So here I'm just going to do 3 times 5, and I'm going to get 15. And then I'm going to do 5 times 2 and get 10. Here 3 times 5 is 15. And then 3 times 2 is what? 6, right? So negative 2 and 6 fifteenths and negative 3 and 10 fifteenths. We're going to use this symbol again because although if this were positive, this would be the one that's larger. Since it is negative, the one that looks smaller actually ends up being larger. And again, I really just did 3 times 5 and got that both denominators were going to be 15. Well, here I needed to do 3 times 2 to get my new numerator, and then 5 times 2 to get this new numerator. So that's why, again, I would prefer, if you're using the cross multiply method, please rewrite the entire thing and don't just be lazy and write that, okay, 5 times 2, this is 10 now. 3 times 2, that's 6. You still need to take the time to figure out what that new denominator would be. That's, again, why cross multiplying works. So for this one, I'm going to kind of do it 2 different ways. This one again, 5 times 2 is 10. 5 times 3 is 15. So this one becomes 10 fifteenths. So this one is going to be 3 times 4 gives me a numerator of 12. 3 times 5 gives me a denominator of 15. Which one of these is larger? The larger one is 4/5. So in this one also, we could change this one pretty easily. If we multiply both 4 and 5, if we multiply them both by 2, this is a pretty way to get it out of tenths. And I can read this as 8 tenths. So it can also be written as 0 and 8 tenths. But over here, this one's not quite as easy to change to a fraction quickly like that. So let's change it to a fraction by doing 2 divided by 3. Remember, it is a numerator divided by denominator. The numerator is the dividend. The denominator is the divisor. And this guy's my quotient. I'm going to add a decimal and a 0. I'm going to put a 0 right here because 3 doesn't go into 2. I'm going to bring my decimal up. 3 goes into 20 6 times, which is 18. 3 goes into 20 6 times, which again is 18. So we should be able to see that we can write this one as 0.6 with a bar notation. Let's just talk quickly for a brief moment. This is a rational number because it can be written with a bar notation. And anything that can be written with 2 integers as a fraction is a rational number. So now we have the 2 decimals, and the way to compare decimals, well, this is an 8 in the 10th place, this is a 6 in the 10th place, so clearly that one is larger. And that one is closer to 1 than the 0.6 repeating. So hopefully that quickly reviewed comparing and ordering fractions. You have to have a common denominator before you can do that, or change them all to decimals.